Let's go ahead and get started. Welcome to the first meetup of DataPub. This online meetup is for people who love public data sets and love to use them either in combination with one another or in combination with their own proprietary data. Over the next few months, we'll bring a bunch of different experts together to talk about the best practices. Please use the Q&A button anytime during the talk, and we'll read off your questions during the Q&A sessions following each speaker's presentation. Sorry. So we have a code of conduct. I'll put the link in the chat bar, but we are very much into practicing kindness here. Our agenda for today's meetup, and we would love to start out by thanking Joel, Jonan, and Saheel for being part of our first online meetup. So now I'm going to turn this over to 𝗥𝗲𝗃𝗃𝗃 for the opening remarks.
Hi, everyone. How are you? I'm Ajay. I'm the CEO, co-founder of Timescale. Timescale is an open source time series database based on Postgres. First of all, thank you everyone for joining our first ever DataPub. A big thank you to our speakers today who will be presenting, I think, some really interesting stuff. And a big thank you to Nico for organizing. In recent days, we've seen many people build really interesting visualizations and dashboards based on publicly available data. And our belief is that, the world is just a better place when we're able to use data to get answers to important questions. And some of those important questions are ones that our speakers today will be discussing. This meetup, our first ever DataPub, is all about public data. And we're really excited to really, provide this forum where we can all benefit from each other's ideas. Great. So without further ado, let me introduce our first speaker, Joel Natividad, who is CEO of 𝗙𝗵𝗽𝗀. Joel?
Thank you, Ajay. Thank you for that generous introduction. Yeah, let's dive right into it. But before I start, let me do a quick primer on open data. As you said, you call it public data. Open data is this thing that's been around for 10 years, this phenomenon of the government releasing data. And during this time, the data that we're all following right now, COVID-19, that's why I thought it would be topical to discuss that. So let me share my screen. Can you see my screen? Great. So, it's all about, flattening the curve and the importance of time series and open data. And it's also a bit of a story and how I, really got to work with the Timescale team. So we all familiar with this flattening the curve. I don't need to explain what it is, but to me, it has a bit of a personal thing because as my wife's a nurse and my brother was just tested for COVID-19 here in New Jersey, which is like the second epicenter behind New York City of COVID-19 incidents. And we're also very familiar with this visualization, right? And the good thing about this visualization is, John Hopkins was good enough to open source the data behind this. And when I was looking at this, late February, I was starting to look at this visualization. It didn't have the kind of data I needed because it was basically not properly formatted. So as it happens, during that time, I was playing around with Timescale. I'm a long-time fan of the technology, especially as it applies to open data in the public sector. And I put in a pull request. I was playing around with one of the examples about air quality data, and there was a small problem with the schema data definition. And I said, I put in a pull request, And as luck would have it, that's the same day as I put in the pull request, Mike, who's the CTO of Timescale, came back acknowledging the pull request and with a request maybe if I can squash the commits. And I told Mike, hey, maybe this you may want to look into this 𝗔𝗍 COVID-19 data. They open source the data, and it's just begging for a timescale treatment. So that was Saturday night. In the intervening day and a half, I decided to write something, basically wrangling that data from 𝗔𝗍's format, which was not really ideal for time series analysis, and making it more amenable to answering some questions that I wanted to answer. So I shared that data, and then the Timescale team was really good, and they actually extended. I was basically just doing data wrangling, and they did an extended treatment of it, and they published this blog post a few days later. It was really amazing how in a matter of days, we came up with this visualization, with this analysis. This is almost like a time machine. This was the beginning of the month, and back then China was still the epicenter of all this activity, right? You see a few clusters here in the US, but sometimes looking back at this, if you look at that blog post, I just basically wrangled the data, and they were able to answer very important questions, like how many cases near me each day. The data was cumulative; it was not on a per incident per day. So using some features of Timescale, we were able to answer things that the data was not readily available. So that's the good news. We got that working. It was, a lot of people started using the utility. We open sourced it as well, but the data was not granular enough because it was covering the whole world, right? And I wanted something that was closer to home. My wife works at Hackensack University. That's where they diagnosed the first COVID-19 case here in New Jersey. And I said, we needed something that's finer grain. So I continued on my data wrangling journey. And I found that a lot of jurisdictions are publishing maps and data. The thing with New Jersey's treatment, though, was they decided to publish a map rather than just publishing the data. They didn't really open source the data feed. So basically, I ended up, I've been in the business of open data going almost 10 years, and I've been helping a lot of governments around the US help communicate with their constituents using data. But I know the reality of a lot of these jurisdictions right now. Open data is the last thing on their minds. They just want to communicate and engage the community. So we decided to just basically scrape the data, right? Nothing fancy. I would just go to that visualization every day and then capture all the readings for that day. But as you know, this is not sustainable, right? This is just something that I was just doing as an open data enthusiast. Also hope so other people don't need to do what I had to do. And with this, we can do certain visualizations, like some simple visualizations, like seeing how things are really going in New Jersey. And that's well and good, right? But as we know, most people in data science, that a lot of our work is exactly this kind of work, like janitor work, right? About 50 to 80% is basically just munging the data, making it data wrangling, so we can actually do the proper analysis. So I continued on that search. Okay, and maybe I can do it for New Jersey, because right now, because I care, because my brother has it, and my wife works as a nurse, so I'm kind of keen on keeping track of the trajectory of the infection. And then on the 19th of the month, I noticed that the New York Times started publishing county level data, finer grain data that I was really interested in. You know, if you look at this, they have almost thousands of counties, and they have a whole team working around the clock, around the world, calling, you know, using the you know, I'm from the New York Times, you know, you get the kind of attention that, you know, a citizen scientist or a public data enthusiast wouldn't get, right? You know, they would basically give them that data, and they had the you know, they published the data, you know, just to run this and to behind this article. And as soon as I found out about this, I sometimes, you know, you never know. You might want to ask and see. Hopefully, they can consider publishing this database as open data, because right after they released that data, the day after, they had another follow-up article from Columbia University, where some researchers, they gave them access to the database, and they had some compelling analysis about the trajectory of COVID-19. And I said, imagine if you release this as open data, what other insights can be had from this database? And even some government officials, you know, knowing what I know, dealing with several governments around the US, that, you know, I know that some of these agencies, they're the primary users of open data. And you know, just kept asking over several days, shortly after they released the data. And while I was waiting for that, I decided to write a scraper, because I said, okay, this is county level data. This is highly valuable data. Hopefully we can, let me see if I can run that scraper quickly. So basically, the scraper uses Selenium. It invokes, captures a snapshot of the map, clears away the pop-up, and then clicks the button to show more, grabs all that data in a data frame in pandas. There are about 2,000 plus counties, so it takes a bit. And my aim was to get this data because, you know, the JHU data was starting to, at the same time while this was happening last week, Johns Hopkins decided to change the data format. So the utility I wrote 2 weeks before stopped working because they changed the data format. So I said, and also at the same time, they decided to remove county data. So that's why I decided to write the scraper. Right, so let the scraper run in the background, and it's done. And then, like late last week, they came out with this announcement. I'm not taking full credit for, you know, I'm one of the few people I know who lobbied New York Times to really publish that data. And thankfully, they decided to publish the data as open data. And actually, this is my tweet shortly after they did that. You know, I said, never mind. I just wrote my scraper. I finished it this morning. I'll take the clean raw data. But when you look at the data, it still has some issues because it doesn't break it down by county. You know, New York City is treated as one big city. For those of you who don't live in New York City being the biggest, most densely populated city in the U.S. is actually composed of 5 counties, or what we call boroughs. You know, Kings County, Manhattan is New York County, Queens County, Staten Island, and the Bronx. So they're treating it the epicenter of everything, which I found ironic because the New York Times is based in New York City, and they're still treating it as this one big entity. So my journey, my data wrangling journey continued. But, you know, fortunately, last week, USA Facts. If you're not familiar with USA Facts, it's It's a nonprofit backed by 𝗖𝗵𝗽𝗽𝗀, where they basically get data from government and try to animate and do some data-driven storytelling. And they release the data as county-level open data. And then finally, I was able to wrangle the data I need, and let me show you where we have it now. So, like I said, you know, I cared more about what's happening in my neck of the woods, New Jersey, because you know my wife and my brother, we're all here. We are directly affected by COVID-19. So let me just get the county level. There with me. There we go. So thankfully, USA Facts released that data. It's clean. I didn't have to do any data manipulation to it. They have the confirmed facts. They have the sadly the deaths as well. They're tracking it. And all I needed to do, because I had clean data, that's basically write a short script in Google Colabs to create these visualizations, you know, just by basically doing some minor manipulation of the data. So basically what I'm trying to say here is, you know, even though there's a lot of public data out there, one thing, and actually I can see a question here, is how do you deal with data that's not stable? And the sad fact is you just have to, you know, deal with it. You know, a lot of the data, you know, especially since the things are changing in a very fast way right now. I mean, data formats and data standards are the last things people think about. You know, we should be grateful these institutions are sharing this data. You know, they're not just giving us a news article, they're not just giving us a map, right? And that's part of the story. And also another thing I wanted to leave with you guys is, and I'll share this slide with Nico, and we can all look at this. Is the journey continues, right? I'm publishing the data. We publish it in our community data portal here in DataBeta NYC. If you guys want to look at the data, we'll scrub it. It has an API. You can, if you want to manipulate the data, so you don't have to scrub it as much. One thing that you can do too, sometimes unlike the great generation where basically there's a challenge, right? You know, you have to go to war, you mobilize yourself. There's an active call to action, right? And sometimes our call to action right now in flattening the curve is basically stay home. But you know, you don't just need to just stay home. Maybe you can look at all these resources, try to reach out to some local officials in your community, in your jurisdiction, share this ability to animate the story. Maybe you can help them. And also maybe you can even give some researchers some data points that might be valuable. Two that I really am a big fan of is COVID Near You. And basically, all they ask of you is to visit the site on a regular basis and to report if you have COVID-19 symptoms. So that becomes a data point for them. So they can see, they can have more sensors, citizens of sensors, showing what's happening out in the community. And another thing that we've been doing here, myself and my family, is, I don't know if you saw coverage of healthweather.us. Basically, you know, if you have one of the 𝗥𝗲𝗃 creates this thermometer, and with the temperature readings, they're able to make predictions of a typical patterns. But it's quite interesting. I highly recommend you look at this article. And what we do is every day we just take our temperature, and that becomes a data point for this prediction too, to see if you're in your neck of the woods, there's some atypical patterns that might be indicative of COVID-19. And finally, around this time, especially for people in the US, fill out your census, right? And it's not necessarily COVID-19 related, but I think we need to, taxation without representation, we need to make ourselves known as we dig out of this predicament, right? It would be good talking about data if the government has more data about us, because they'll need that data to really make some tough decisions after we recover from this debacle we're dealing with, which we will. But yeah, that's my call to action, is participate in the citizen science resources. Open data is not just the government giving data or academic institutions giving data. It's about having this data commons, this data conversation. And that's it. Thank you.
Thank you so much for that, Joel. That's definitely just very helpful information during this time. If you have any questions and answers, please put them in the Q&A chat box. We do have a question for you, Joel, from Prashad. There are a lot of data sources out there that would be amazing if they were public. Do you have any tips for reaching out to some of these companies, or do you just scrape and ask for forgiveness later?
Yeah, I mean, right now, you just scrape and ask for forgiveness. I mean, that's asking for permission, ask for forgiveness. That's always my go-to thing. But at the same time, as you saw, it doesn't hurt to ask nicely, because they might say yes. You never know. And thankfully, New York Times is forward-looking enough to say yes. Okay, we'll release the data.
Great. Anybody else have any questions out there? If not, also, Joel's information will be also provided in slides, and you're more than welcome to reach out to him via Twitter, right?
Yeah.
Okay, good.
Great.
All right, perfect. So, move on to our next speaker. Thank you again, Joel.
Mm-hmm.
So, just sure. Great. Sorry about that. Okay, so our next speaker is Saheel Ahmad. He is a data analyst with Blue Sky Analytics. Actually, I'll stop sharing my screen so you could share yours. Oops, unmute.
Is it visible?
Hi, Saheel. I need you to go ahead and start sharing your screen.
Is it visible now? Hello.
Oh, I can't see anything. It's no, there's no screen showing at this time, Saheel. Probably. There you go.
Now?
There you go. Yeah.
Yeah. Okay. Okay.
Thank you.
Hi everyone. It's nice to be a part of the first virtual meetup. Bit about myself. My name is Saheel Ahmad. I'm a data scientist at Blue Sky Analytics. We are a geospatial data intelligence startup working primarily towards climate change and environmental risk, solving critical environmental challenge like air pollution through satellite data and machine learning. We are the winners of 2019 Copernicus Masters and MIT Solve. So let's first understand what exactly a TIFF is and what are the problems with the current file format of satellite data. So a TIFF is a tiled image file format. It's a compression format for images. It's a completely lossless compression, so you won't be compromising on the data quality. You can edit and resave the data with no loss. You don't see this file format very often because of the size. A TIFF file is relatively higher than, say, a JPEG or a PNG. So mostly TIFF file is used in, say, satellite imagery or medical imaging. A geoTIFF, however, is a kind of TIFF, but with embedded georeference. A georeference tells where on Earth this image is taken from. So basically, it will be a series of coordinates that allows an image to project on the map. And that's one of the standard file format we use on the satellite imagery. Now, what are the challenges of our current file format? The first being the file size. The file size of any raw satellite data is huge, and whenever you are downloading and moving it around, it's create a pain. Again, when you are creating multiple copies of a satellite data, you're basically duplicating it and you're not using it effectively. Third being, you cannot create a web service around this data because loading that data on a dashboard would create a latency and won't be an efficient process. Considering these things in mind, why can't we create a new structure for the current satellite data? This is a cloud optimized geoTIFF. This is exactly like a regular geoTIFF, but it is aimed to be served better on a file server. Now, how do we do that? We use techniques such as internal tiling and overview that gives a better internal structure of the file data, including compression. And so basically, a 𝗏𝗏 doesn't just store the raw pixel as it is, it organizes them as well. Now, when you have a data in a certain format, you also want the web or the websites to support it. Using a feature of HTTP called range request allows you to access a portion of the data without downloading the whole file. So if you have to analyze only a certain part in a satellite imagery, you just will be downloading that part, not the rest. That allows a fast streaming and rendering on the fly. Internal tiling is one of the techniques we use for structuring the satellite data. What it does is, so a regular geoTIFF is stored in manner of stripes, just like the mention on the slide. In order to read a single stripe, you have to download the whole tile. While what internal tiling does is, it breaks the tile into smaller blocks and saves the coordinate of those blocks in the metadata as offset. So if you want to read any block, you just have to pass the window coordinates for that, and it will download in only that section. And you don't have to download the whole file. Internal overviews are a downsample version of the original data. So, or should say a zoomed out version. So basically by providing multiple overview levels, you're basically giving a less detailed version of the original data. And you're not loading original file every time it goes to a different zoom level. Now it increases the size of the file, but you can compensate it with internal compression systems. This is the final structure of a 𝗏𝗏 or a cloud optimized geoTIFF when you apply internal tiling, overviews, and compression. So you have metadata at the top, which has all the coordinate and the offset values of each tile, followed by different level of overviews or zoomed out levels, and then the final raw data. And each of them are internal tiles, so you can access them individually. Now, like I said, we have created a better structure, and this will only benefit if the web supported. So HTTP, there's a feature in HTTP called range request or byte serving that allows client to access only portion of data. This is the same feature that allows us to watch YouTube videos without having to wait for the entire file to download. We can go back and forth without having to wait for anything. This feature is not compulsory for every web server because range request is an optional field. But most of the cloud storage options like AWS, Azure support this service. So almost all the data that is stored on cloud is basically available to be downloaded in parts. The client just have to send a request for a particular window. Now, what is the power of Cloud Optimize? Well, you can load any number of tiles by just specifying the specific coordinates you want to capture. So for creating a mosaic where, let's say, a single tile won't represent the entire area of interest, and you have to download smaller chunks from different satellite tiles, you can create on the fly. You can create, a common example would be a tile server. You can load multiple tiles and it will load each tile in a chunks. In fact, we are building a tile server on our own, and we have created our entire data pipeline based on Cloud Optimized geoTIFF. In order to create a geoTIFF, you need to use a library. GDAL is one of the go-to library for creating or for reading rasters. In order to use that, this is a command line instruction. You have to first install a GDAL library. It might take some time because it's not a straightforward approach. And the command says it's translate an input source file into an output by passing command line arguments such as tile and copy source overviews. So it is assuming that the overviews are already in the source file. And if you don't have, you can run the second command to create overview. So 2, 4, 8, 6 are different level of overviews or different level of zoom. And again, the compress is 𝗵𝗫𝗃, so it gives an internal compression. Thank you, everyone.
Thank you so much for that, Saheel. Does anybody have any questions? We don't have any questions at this time, but please feel free to reach out a little bit later, and definitely be happy to get you those. Thank you again. So the next person. All right, so our next person is Jonan. So he's a developer advocate at Timescale. So we will get him going.
There I am.
Hi.
Hi, everyone. How's everybody doing? It's a little bit strange doing a virtual meetup because normally you would answer or like there would be applause. I'm just like talking to my camera alone in my office. It's kind of a lonely experience not having a proper stage. Let me see if I can figure out how to share my screen here with you all. I have not the things that I thought I had. I'm sorry, just one moment, everyone. Let's see. There we go. Okay. I think I can share this way. To there. If I share Keynote thusly and then I play, do you see the whole slides? No, you don't. You just see one slide, I think. Bear with me. How about now? Anyone? I see people typing. Chat's clapping for me. Looks great. Okay, we got it.
Good.
Sorry. Here we go again. All right. So I had to adapt the title of my talk here a little bit for you. We had, I think it was query optimizations, common query optimizations. And I decided that Animal Crossing was maybe a little bit more relevant to what's been going on lately, because apparently that's all people do. I'm not sure how everyone around me in the developer community has so much free time now. But having been someone who works from home for a long time, this is not a new thing for me. I'm still just hanging out up here in my office, talking to people remotely instead of getting on stages. So this talk is titled Faster Queries, so you have time for more Animal Crossing. And real quick, this one company, Timescale, right here, that's where I work. For those of you who are unfamiliar, they make a beautiful time series database. I hope that you happened across this particular meetup because of Timescale DB. But if you haven't had a chance to play with it yet, I have an exciting chance for you to do just that here in a moment. So I was looking for some public data to use for this talk. I wanted to walk through some of the mistakes we've seen at Timescale. I think mistakes is probably an overstatement. Some of the counterintuitive bits of SQL that you can find yourself in that create slow queries for you. It's often difficult to identify those things. I've got a couple examples for you that I'm going to get into in a moment, but as I'm looking around for public data, the COVID one, I knew we already had a speaker about, although it's a great public data set, and thank you very much for your help in getting that to become a reality. I have a really good looking t-shirt. Thank you, Linus. I agree. Looking around for public data, I stumbled across this Wikimedia Foundation stream. I like live streams for my data. I like to have my data by the second as it's produced. And that's another thing that was very frustrating about some of the COVID data. They're updating it as many as 3 times a day. I understand, of course, that is the result of a Herculean effort. And again, I applaud you for that. But that's just not going to do it for most of my data needs. I like to have things up to the minute. I love those live streaming data feeds. And I found this one from the Wikimedia Foundation that is actually a stream of all of the edits to all of the Wikimedia Foundation's web properties around the world in real time. They have a Kafka queue that they've tied up to this API that you can stream from. And so I can get edits on all of the different pages around the world, not just the wiki pages, but Wikimedia actually has a lot of different components and different pages that they support. So I went digging around looking for someone to tie into this stream, and I happened across a little library online, like a little bit of abandonware from maybe 3 years ago that somebody put up there. I think someone who works for the Wikimedia Foundation, little Python package. And I'm not a great Python programmer. You're going to have a chance to look at some of my Python code here eventually, here in this repo, even actually. If you go to Wikistream Docker, which I've just made public, I hope, you can go to timescale/Wikistream Docker, and I have created for you a Docker Compose file that will spin up locally a Timescale database and a Grafana instance, and then this little package that I wrote, my very first Python package, Wikistream, I wrote to pull down from this feed, kind of stealing some code from wherever I could find it, and referencing it with sources. You'll find those in the Wikistream package. If you have any advice for me on how to properly create a Python package, please help. Yes, please, Saheel, it's there in that repo. The Wikistream Docker repo uses the Wikistream repo, which I think actually I may have forgotten to make public, but I will make public very shortly. And if you give me some advice, I would really appreciate it on how I'm doing things wrong. One of the things that I know I did, I actually had to entirely subsume this other package that I was trying to get because we were using different package managers. I was using Poetry. In any case, Wikistream Docker, you should be able to just pull this repo down and say Docker Compose up, and you'll have a Grafana instance and you'll have a Timescale DB running locally, and Wikistream will start up and start streaming events into it right away. And it'll look something like this when you get into your Grafana dashboard. So this is just the one dashboard panel that I made, and it's a simple time bucket. It's showing you all of the edits across a number of Wikipedia pages. There we have the English one, and we have French and British, and I think Japanese on there. Yeah, we have all of the 4 sites that are listed there, but I mean, again, there's everything that you would want in there. So you could make this graph much more interesting. I was trying to kind of experiment with making extraordinarily, to make more query problems for myself. So I'll get into that a little bit later. But the dashboard that's in there, go in there and play with it, make a new dashboard. It's very easy to contribute those back too. If you go and you edit this dashboard and come up with a new cool looking panel from this data set, please contribute it upstream. You can actually export, there are instructions on the repo. You can export your dashboard, all of it, and then just pull request it. I will merge your pull requests very liberally. I would love to see some more interesting data panels show up on this dashboard, but the Docker container's up there. Please go ahead and play with it. So this wiki stream package that I wrote is writing to our events table here. There's a database created in Timescale DB automatically for you called wiki stream. And then I have an events table in there. And events has a few different fields on it. We've got the timestamp that we need, right, with time series data. We have the wiki user, the actual user who submitted the request. And if you get a chance to go into that dashboard, you'll see that I'm actually using the user to search for users that have bot in their name, so I can ignore the bots. I want to strip those out and just see the actual edits per second on each of the different properties. I also have a comment length that was more just so I had an integer in there that I could work with. And then it's also kind of interesting to see the length of comment based on the country. Some people tend to be a little wordier than others, or maybe it's just that there are edits that are happening on properties that are not actual wiki pages, right? Because if they're just changing an image, then the comment length will be short. And then I'm actually lifting the domain out of the JSON that I get from the stream, and I'm dumping the entire JSON response into that JSON-B column there. So you can go and dig into that with you know, the JSON-B query methods, but the rest of the pieces there are there for you to work with a little more easily. So I set out here to find some interesting pieces from my data. And the first thing that I did was I used this common table expression. I am still a relatively new SQLer. I came from the world of web application development. So I've mostly lived within ORM my entire 8-year-long programming career. And I, of course, have had occasion to get down into the SQL, but I am not even close to approaching a DBA, as I imagine many of you are. And you're all a very impressive bunch. But here I'm setting out to select you know, everything from my events table, and it just makes sense to me that I would start with a common table expression. And I think probably some of you can see where this is going already. But I'm going to explain exactly what happens here with this common table expression. So we've got our explain plan here. And I'm generating this with explain analyze, right? And there are a couple of things that I'm looking at when I'm looking at this explain plan. I'm going to zoom in a little bit, enhance. And I can enhance again. There's a double enhance. Now you can see down at the bottom, right, our execution time. This is a lot of milliseconds. I think that's like 18 seconds or something. It's not 18 seconds. I can do millisecond math. I may be just a web app guy, but I can do that. It's still pretty slow though, right? We don't have that many records in our table at that point. It shouldn't be taking that long. Another thing that I'm noticing here when I'm looking at this, I've got this scan up here, right? Then I've got another scan down here. And that's not something that I would expect when I'm just selecting, right? Well, that's the common table expression, right? The advantage that a common table expression affords us is actually that it's going to cache that scan, that first query. It's going to take that CTE, I think I named it, and it's going to set it aside, right? But it's going to run that, and then we're going to be able to use it again throughout our query. The disadvantage there is that we actually have to run the query twice, right? We're scanning the entire table here 2 times. Even though we have our filter, we're only applying the filter after we have scanned all of the records, which is obviously not a very efficient way to query. Now, common table expressions are incredibly valuable if you have a really long query and you're going to be using that cached bit over and over again in different ways, then obviously you're going to eventually get a speed advantage out of this, right? So I realize my query is slow, right? I don't know really how to fix it, but I'm going to change a couple things arbitrarily because that's what I'm doing. I'm mucking about in the database. So first I'm going to create this index, right? And then we go back and we look at our table. There's my index. The other index we have there, that events time index, that is a function of this being a hypertable. Hypertable is a construct in Timescale DB that does a lot of very interesting things for you. It makes everything quite a bit faster, organizes your data very tidily for you, enables some things like compression. We're going to talk about in a moment. If you are not yet a big fan of Timescale DB, you should be. And not just because I work there, because I was able to build this whole dashboard with it, and I have yet to overwhelm this database. I'm already sold on this, obviously, because I came to work here. But if you haven't had a chance to play with it, I encourage you to go get that repo. It's a very easy way to get started. So now I'm going to run my explain again, but I'm going to change my query a little bit, right? I'm going to get rid of that CTE that I had in there. And we'll see if we got to move faster. And ta-da, huge improvement, right? You can see actually the speed is significant, right? Even for such a small query when I'm not running those. And it's specifically for smaller queries that you wouldn't want to use a CTE, because again, if you're going to be using this over and over again, it's going to make sense to cache that scan and then use it throughout the rest of your query. So this also, I noticed, did not say index anywhere in it. And I don't know very much about indexes or explain plans, but I would expect that if I had an index, I would have an explain plan that would show me something index, right? So let's go back and look again at this query. You can see that like there. And the like, unfortunately, does not use an index because we are not looking specifically for the string we want. Now, I know what I was trying to achieve here was I was actually just going to look for all of the 𝗵𝗵𝗽𝗃 properties, right? So we go back here, and you can see then that I replaced the like with my enwikipedia.org, and that's actually finally going to use my index, which is what I want to achieve, right? And the like actually can be used with indexes. There is a extension called PG. I want to say it's TGRM, PG or TRGM, PG trigram is the thing that you're Googling for. And that is a way to enable indexes for like and I like being the case insensitive equivalent. You'll see that I use it in the dashboard on Grafana. But if you want to use your indexes with those regexes, you're going to need to use something like PG trigram. This is not a feature that is supported by Postgres out of the box. So I want to move on from my Wikimedia app, and I want to talk about a problem we found that's a little more timescale specific with one of our customers, and was particularly interesting to me because it was something that I would never have seen coming. So they showed us this table that they created, and there's a ... in here. There are presumably some other pieces in this table, but none of those are relevant for our discussion today. We've got this ID here. It's a big serial, right? And we have an asset ID as well. That's a varchar. A varchar, what do people, I would say care, varchar. Asset, I'm sure that there is a way that DBAs say this thing, and everyone is very judgmental of it. It's GIF and GIF simultaneously. Actually, if you think it's GIF, you're a monster. That's not correct. Asset int8, and those are our three fields that we're dealing with here, right? So we have this feature in Timescale that is compression, and you can in fact you configure compression on a table by altering the table like this, right? You alter your table and set this compression up, and you choose something to segment by, right? So in this case, our customer is segmenting by the asset ID on that table. So again, if we look back at our schema here, this is the varchar that we have there. They are going to be segmenting their compression on that, and then they're ordering by the timestamp and the ID, right? So the compression in Timescale is fantastic. I had a job running. There's actually a job that sets up automatically in that demo Docker container. It runs, I think, every 10 minutes. to keep your hard drive from filling up from downloading the thing. But I had one on another similar Docker environment that I was using that I think went from maybe 3 or 4 gigs down to 50 megabytes or something. It's absurd. The compression is fantastically good, and you should definitely be using it. And these jobs you can schedule to automatically compress for you when you get to a certain point. And if you combine that with the drop chunks policy, the 2 different policies in Timescale DB, then you are able to compress the data after a certain interval. Compression's not a great idea if you're still going to be writing to it actively, right? But if you're using something like a stream, I know that Wikimedia is not going to hand me an event that's more than 10 minutes old because I've been watching the data for a while, right? So I can compress at 10 minutes and know that thereafter I'm only reading from the data, because I can still write to it, but I'm going to have the inefficiency of having to decompress and then write and then recompress the data. So I wait until 10 minutes and I compress it, and then eventually I can just drop the chunks off the end, and I don't have to worry about my disk space growing at all. I can figure out how long I want to keep my data around, and I can drop off the other with a drop chunks policy so that my database never grows above, you know, whatever fixed, maybe a gigabyte I decide that this Docker thing is allowed to use. And even better, actually, there's a feature called continuous aggregates. If you're going to set that thing up, that you want to look up, because continuous aggregates will allow you to kind of roll up the data over time rather than just losing it all as it disappears. So when you drop those chunks off, say I want to keep a week worth of data, when I'm dropping the chunks off after a week, if I'm using a continuous aggregate, I can actually keep that data around even if the underlying data has disappeared. So you should go and look that up if you haven't had a chance to learn about those features yet. But this compression feature that this customer is using, where we're compressing by the asset ID, had kind of an interesting problem with it. So the Timescale underneath the hood uses this concept called a chunk, right? Which you can think of as a partition. And the customer is selecting here from one of their compressed chunks. And they notice that just this simple select, right? They're just selecting from the chunk, and they get a huge slowdown here. That they've got 26,000 millisecond analyze here for their select on this chunk. This is a very long time to be doing that thing that they were doing. And they did it again with that integer that I showed you earlier from the schema, and it was very, very fast, right? So they were mystified that maybe there was a bug in our code somewhere that was just doing this for all strings, right? So here is the thing that I wanted to talk about here. If you look carefully into this explain plan, you'll find this piece here. This, if you look, is casting, right? That text, the : text is casting the asset ID to a text field on both sides of our equality comparison. Now, it's kind of a strange behavior. I wouldn't expect Postgres to have to do that. We said it's a varchar, it's a varchar. The thing is, like, we don't actually, in Postgres, have very much occasion to be using that in the first place. This varchar is a thing that I used a lot in my MySQL days, where I had to guess how big someone's last name might be and usually be wrong and break my application. And it's not a thing that we have to do anymore, right? Because we have the text option. And I was reading online when I was doing some research for this talk, and people are advising each other on places like Stack Overflow that you should never use text because it's not portable. Text is brilliant. Please use text. Text is as fast as varchar in all cases. There's no slowdown or no real cost for you. I shouldn't say all cases, because I'm sure someone out there is shaking their head and will actually mean, but as far as I know, there is no real performance hit for using text instead of a varchar. But what had happened in this case was that because they have this, right, and because in their original query, they hadn't cast it. If you look up in the top right there, they're pulling this asset in here. Now Postgres decides that it needs to cast it into a text on the left side of that equality operator. And what that does when you're using Timescale is it actually happens before the compression. So it prevented them from taking advantage of the compression in Timescale and slowed them down significantly. And if you find such a problem in your own adventures with Timescale, then all you have to do is this, and explicitly cast your type ahead of time. And you will have a significantly faster query than you would have otherwise. Or just use text in the first place, which I would advise most every time, unless you have a specific constraint where you need to have that length, like you never want someone to be able to enter a password that is more than 8 characters long. But please don't do that. It makes you a really bad person. That's all I have for you today. Thank you very much. I look forward to questions, comments, concerns. Go and check out the repo. I worked really hard on it. Thank you.
Thank you so much, Jonan. Does anybody have any questions that they'd like to ask at this time? Oh. Jonan's also very easy to get a hold of, the Jonan Show via tweet. So we are done. We went a little bit over time, so sorry about that. Once again, thank you so much to our speakers. Thank you all again for joining us today. Please let us know if you'd like to present at any future meetups that we'll have. And we hope to see you for our next meetup on April 21st. So please look out for that information. All right, once again, thank you, everybody.
Thank you.
Thanks,
And,
everyone.
The repo with the broken scraper, that will be fixed this week because Johns Hopkins finally finalized their data format. So just FYI. Thank you.
Have a good day.